Good morning, good evening, or good afternoon, depending on where you're joining us from today, and thanks for attending the 5th session in our Azure Cosmos DB technical training series, Understanding Operations of Azure Cosmos DB. Before we get started today, there's a few housekeeping items that I'd like to address. If you take a look on the left-hand side of your webinar console, you should see a Q&A box. We have a few Azure technical experts here who would be happy to answer your questions. We will also spend a few minutes at the end of the session answering your questions over the line. If you take a look on the right-hand side, we've provided a few resources that we think you may find helpful throughout the duration of the session. Below that, you should see a survey box. We would really appreciate any feedback you have about the content of the session and what you may be interested in learning about in the future. So also, this presentation will be sent to you at the email address you registered at within 48 hours of this recording. So with that, I would like to introduce today's speaker, Govind Kanchi.
Hey, thank you very much, Nick, and thanks everyone for joining so early in the day or so late in the day, depending on where you're joining in from. My name is Govind. I work out of the Cosmos DB engineering team. And today what I'll be doing is walking you through the operation side of the Cosmos DB, right? So what is the operations of the Cosmos DB? Before we do that, there are a few things that I would like to basically go through. One is, if you ever have any question on Cosmos DB, you can reach out directly on the email. Of course, if you have a support channel, that works better. But if something cannot wait, this email alias is perfectly fine. And then you can ask us a question on the Twitter alias too. We actively monitor it as we go along. Okay. So this will be the one slide deck where we don't have the Uber Cosmos DB slide. And I'll be directly getting into the operations. And idea here is that you know some part of the Cosmos DB. So the key part of Cosmos DB's pitch is that end of the day, Cosmos DB as a platform takes care of providing throughput guarantees, providing low latency guarantees for point read and writes, for providing distribution guarantees across the world with consistencies. And when we provide the low latencies for read and writes, we basically perform durable commits and auto indexing of the data. Right? So these are the core capabilities. And on top of that, we provide various data models and data APIs for you to interact with. So with that said, if you have tens or hundreds of terabytes of data within Cosmos DB, what are the few things that you need to manage or monitor? Right? Because we seem to be doing most of the things. But the key part here is that you need to design first, which is get the data model right. As part of that, get the partitioning right. As part of that, get the throughput right. If you get the partitioning and throughput right, pretty much everything is taken care of by the Cosmos DB platform, right? So what do we do normally when we have a large database of any kind? It doesn't have to be hosted, can be managed by yourself. There are majority of the things that we spend time on is performance management, the capacity management, which could be storage or which could be compute and so on and so forth. And finally, the availability management, right? In Cosmos DB, so how do you manage all these things or monitor these things, right? First of all, what do you do for the monitoring? And then we'll look at how do you do all these things. So first thing is what to monitor. So what you want to monitor is we provide a matrix, which I will just share my screen. And let me know when you can see the screen. So we have a screen, we have a detailed information about how do you monitor your Cosmos DB instance. So there are a few things. There is a matrix portal, matrix part of the portal, and you can go through it. I'll be walking through the exact same thing as we go along. But let us look at the screen itself, right? So what is it that we need to look at? When you log in into Cosmos DB's particular instance, what you will see is an overview if you come to the matrix part, right? Which will basically give you a high-level view. There is X amount of data, and at per minute level, this is if there was some kind of throttling happening, it will tell you right at the back of the hand. But what you really need to do is you need to start from the storage. you need to look at the latency, which is the server-side latency, which basically where we provide the latency for P99 for reads and writes. The writes will take always less than 15 milliseconds for 1 KB of data, and reads will always take less than 10 milliseconds for 99 percentile. Right? These are the guarantees that we provide at the back end, which you can trust and take bet with. The other piece is the availability. We also provide 4 nines within a region. We announced 5 nines across the regions for the reads, and you will see some exciting announcements as we go along. Right? Anything by default. Right? If you want cross-region, I will talk about it a little later, how to add and how easy it is to add multiple regions within the Cosmos DB, that being the core platform capability. Right? Then what do you need to look at? The key part that you need to look at is the storage, and we'll get into these storage best practices as we go along. But what you need to find out is how does the storage look like? So you basically would spend time on the first chart, which is basically saying data and index consumed, which is, looks like my total data is pretty less at this point of time, 9 GB of data, which includes the index as well as data. You need to focus on how is your data and index distributed across the partition key range, and we will discuss these concepts as we go along. But you should see a good uniform distribution. It doesn't have to be as equal as it is coming down here. Plus minus 10% is completely okay, but drastic deviations will not be so great, right? So this is one set of things that you will be looking at, right? Let us take an alternative view. Let me see if there is something which is present, right? So let us take an alternative view which is showing something something you should be alarmed about, right? If you see a particular partition key which is taking more space than everybody else, then there is an issue, right? So this kind of distribution should not be there. You should not see anything like this. You should always see basically this particular data plus index storage consumed by top partition key should be pretty clean, generally pretty clean, right? Few of them from time to time is okay, but generally it should be clean, right? So this behavior that you see here, where Seattle as a partition key is dominating, should not be there. Similarly, here you can pretty much see that when you click on this particular physical partition, or what we call as partition key range, you will see that Seattle as a partition key is a resident on that particular partition key range, and it is occupying pretty humongous chunk, almost like 172 megs, right? Now, what you can definitely do is you can find out what that information is all about and so on and so forth by opening that data and finding out why did you actually design it that way and that's why it is landing up there, or is it by some other mistake, right? So we'll discuss how to tackle some of these kind of issues a little later, right? So this place, the matrix is your location where you will spend maximum amount of time. What is the other thing that you will manage or monitor, right? You will be looking at this particular piece, which tells you how many requests are coming in, how many requests are getting throttled, which is number of requests exceeded the capacity, how many requests are consumed, or rather max consumed RUs per second per partition key range, right? And when you click on this, you can actually go down and find out what was happening at a given time. You can enter the time here and find out what was really happening. And you should see a uniform distribution of the throughput, right? So I have covered a lot of ground here in very short amount of time. So let me just switch back to cover some of the concepts, because this is all that you need to do, right? And let's get back into a little bit more details as we go along, okay? So as we were discussing, the majority of time that you will spend is using those metrics, creating the alerts, ensuring that your data distribution is not skewed, ensuring that your throughput distribution is not skewed only towards certain partition key ranges, and making sure that your latencies and availability is as per your SLA, right? And this is all provided out of the box. If we deviate, we provide alerts on these, so you can tap into all those alerts too. I will also provide you later on something else which is coming up, and some of you, I'm sure, are already using it. The Azure Monitor. We started exposing a lot of these key metrics there for your benefit, so that you can do programmatic access against all of them, right? So let's just do a little bit of recap of the whole RU, because I'm assuming some of the folks are completely new, and I just got directly into the monitoring part, right? So what is RU? So as you can imagine, RU is the currency, or it's called as request unit. It is the budget that you provision for your container. And container could be a collection, container could be a table, container could be a graph, and so on and so forth. The key part here to remember is that throughput is equally distributed across partition key ranges. And partition key ranges are transient. As soon as you choose a partition key, we decide, and you choose a throughput, we will make sure that you get enough partition key ranges to place your data. And as your data grows, we will add enough partition key ranges, and we will ensure that you get throughput to go along with that partition key range. So you don't have to do any capacity management at the storage level or at the throughput level, right? So everything is basically taken care by the Cosmos DB platform. Now, for folks who are really interested, right, how do you create a collection and how do you provide a throughput and all those things? So let's take a brief look at that too. Let's say what you can do is go into an existing, or let me go here, and actually let me first share the screen, because you will not be able to share the screen unless I do that. Go to this. So there are few things. When you create a collection or of any kind of container for that matter, you will be able to choose what we call as a throughput, right? So the moment you provide the database, you provide the collection information, and you basically provide a partition key, and this is the most important part for you to distribute your data very well. So there is a fine line how to distribute your data very well and how to keep data close together. And then we have guidance around all of these. So there is guidance in how to do partitioning in Cosmos DB. The key part here being Cosmos DB can scale infinitely, and you have to choose the partition key which will scale out and which will allow you to keep data together, which you think is important. So let me give an example. Let us say there is a sensor which is spewing out some data. You think that data will be less than X amount, or less than 10 GB for a particular time frame, let's say a year or so, right? And you can TTL out any rest of the data. So you would choose a sensor as the partition key, right? And store all the data related to that partition. And you don't have to do anything. You just provide a partition key and you push in the data, and we will do all the necessary things to co-locate that data, right? When you do the query, you will be able to pick up the data only through that partition key. So that's the key concept for that particular piece, right? So that's why partition key is very, very important. Second part is this whole throughput. Throughput is you can start from, you should definitely choose unlimited so that you can go as much as you want. And when you provision, as you can see, you can go to 100,000 RUs in this particular case. But if you want more, you can definitely approach us. You can create millions of RUs containers, right? And this is the key part. What is this RU or a request unit? Again, this is the a minute. Okay, I think I will just repeat the two pieces here. One is that there was a partitioning, which I rushed through when I was trying to say it earlier. So the partitioning information is available at this particular. You can just look up into your favorite search engine, just say Cosmos DB partition, and basically you should be able to hit this link pretty much in the first two, right? Because that's the key part that you need to spend time on. before embarking on any Cosmos DB application. So you should get this piece right. And the key concept here is how to distribute data very well, which can, and how to co-locate data which needs to stay together so that you can minimize the fan out of the query, right? So this is the key concept of the partitioning, right? And how do you provide the partitioning key? There has to be some attribute within your data based on which the data can be distributed across, right? The second part, as we were discussing, is the request unit, right? So we describe in a lot of detail here about what the request unit is, and if you have attended our earlier sessions, you would understand what a request unit is. It is a currency that you provision, it is the budget that you buy, and at per second level for all the operations that you do against Cosmos DB, any CRUD operation, right? And the way you calculate the request units that you require is using a calculator. So you can use this calculator, and you can provide, depending on the API or depending on the representation of your data, you can upload the single instance or multiple instances depending on the update and delete, and then basically provide the number of instances of operations that you do, right? The one thing which you will have to do, one extra thing, if you do query with filters, you need to take that information separately because the query calculation of RU is not here. So you need to basically do that separately, saying that, okay, I'm going to do X number of queries. Let me add that data also. Okay, so that's the key part of the Cosmos DB. So I was talking about the throughput, right? So the two pieces. One is the partition key, second is throughput. And throughput, you can provision as much if you want. If you want something more than this, just reach out to us. You can create up to 1 million directly from the portal, or you can come to us and we will help you create 5 million, 10 million, whatever, 20, 30 million RUs per second, right? So that's completely possible. The only reason we don't expose it, we are a provision model, so we don't want customers to basically get charged, because moment you provision, since we provide guarantees for performance, for throughput and low latency, we reserve, we basically isolate your environment and we provide, that's how we are able to provide those guarantees, right? So we start, so the meter starts kicking in the moment you provision this. So this is the key part. But of course, you don't have to do this way. You can always automate all this stuff out. You can use, this is the GitHub that, so if you want to provision a collection, so you will get as much detail as you need, right? With examples. So how do you provision? So you will provision by providing the throughput information, right? And providing a partition key, right? So that's another way of doing that. So you don't want to do without providing a partition key. Please always provide the partition key. That's the best practice, and that's the only way you can have unlimited amount of data. Okay, so that's the key part of the Cosmos DB, the partitioning and the throughput. And I'll not spend more time on that. I will just make sure that everybody is in. If you have any questions, I can answer them offline on email. My email will be there, or our email alias is there. But that part, if you do well, then what is it that is required, right? So let's come back to this side and then discuss some of the other things. So you can create a collection or a container through an API, pretty much across all the APIs. You can change the throughput at any point of time, and that is instantaneous. And I will just get into that a little later. There are few operations like a TTL which does not use an RU, right? The RUs used by the SQL query can change based on the number of entities which are valid for the filter condition. And this will be apparent when we discuss the SQL query execution matrix. What that simply means is, let us say you had 10 rows which were valid for a filter condition where city equals Seattle, right? And now you inserted more data, and after some time that data, the filter condition had 10,000 rows, right, or 10,000 entities. Now, they are all valid conditions, so definitely your RU for the query will change in that respect, right? So that's the key concept to remember. What doesn't ever change is point lookup and point write, right? That RU will never change. What is that? That's a very simple way of saying that you are writing an entity with an ID and a partition key, or reading an entity and with the partition key and ID information that you defined. In that case, that RU is never going to change. So what is an RU? RU is the amount of resources that we take to provide you 1 kilobyte of information. And how do you calculate it? You basically add the number of operations, update, delete, and insert, and give the entity which is going to do that operation, plus the query. That's what the RU is all about, right? How do you scale up or scale down? I will need to switch back just a minute, and I'll show you that again. And let me know. Okay, is it okay? I think I should wait for this guy rather than just dumping. So let's see. So how can you scale up or scale down? So let's stop this. This will take, it is instantaneous creation, but you can also scale up or scale down instantaneously. This is at 10,000 RUs. You can make it 20,000 RUs and so on and so forth. This is instantaneous. You can scale up and down as many times through the day. We charge you whatever is the maximum in a particular given hour, right? And that's the key part of the Cosmos DB. There is no limitation in number of times that you can increase or decrease it, or there is no limitations around that, right? How would you do this through the code? You can do this through the code too. So what you can do is, I'm assuming that you can still see the screen. So what you can do is change the performance correction. So there is a concept in Cosmos DB called as offer. Offer is basically which represents the throughput associated with a resource, in this case the container, and you basically go ahead and create a new offer, and you replace the new offer with particular RU. So it is always in the increment of hundreds, but you can change from say 10,000 to 100,000 instantaneously. There is absolutely nothing stopping you from doing that, and that is the guarantee that we give you, the instantaneous throughput guarantee, right? So that's the key concept of the whole throughput side of the things. What about monitoring it, right? So let's come to the monitoring part, and let's understand a few bits about it. So how do you monitor the throughput? So you will come to the throughput. You will basically find out, so what is your goal in the whole monitoring of the throughput, right? First thing is to look at, okay, number of requests. But now you see that this data is at a per hour level. Ideally, what I do normally is look at 7 days. So then you and I can get a overview of what is really happening. Oh, looks like this was really active yesterday, but now it has come down, right? And then you can see that there are some throttles also happening. And we will cover throttles if people don't know that, but it is expected. Let us say you provision something and then you exceed that provision capacity, we will throttle you, and we will basically tell you how much time to wait before retrying that operation. You don't have to do much there. The SDK will retry X number of times, and you can override that behavior. But this is the key concept that you need to do, is find out, are there any throttles? Your goal is not to have 0 throttles. Your goal is to find out if there are certain set of, if there is a pattern in the max consumed RU per second per partition key range, right? What is partition key range? Partition key range is internal transient concept where over which the RUs get distributed. So when you create a container, we create partition key ranges, and your throughput is actually distributed equally across all those partition key ranges. And your partition keys themselves are sitting on one of those partition key ranges, right? And as your data increases, we'll increase it. But the key part here is that you need to focus on, is there any pattern here? Should have I provisioned very less? Looks like per partition I have got only 2K of data. Should I make it 3K? Or should I make it 4K? Then that's the decision that you need to take, right? That's the key part. Or is there any cycle in this? Do I see that I do a batch job in the morning, so I can increase it by a web job, by coming to portal, or by SDK, or by Azure function, just increase it in the morning or evening when I do ETL jobs, versus, okay, I think that the throughput is going right now increasing. Let me go ahead and increase it or decrease it, right? Because you want to save money. So that's the key part. Once you find out there is certain kind of certain time that we have exceeded the capacity, you can take this time, which is about, let's say, 1 a.m. or so, right? And you can come back here, if I can, that is, let me just a little bit of time to do that. Let me do that again, and let me come back. Let's come to throughput, and let's come to the one which is active at this point of time. So what you would do is you will enter the time, which is maybe it was about 1 a.m. or so, something like that. It looks like 1 a.m. And then you will come to know whether there was a particular partition key range which was getting impacted. You should see something like this. What you should not see is one of these partition key ranges are getting pounded very heavily. If that is the case, then we need to find out the reason. Maybe there is a partition key or set of partition keys which are very hot. There is a pattern to handle them. I will discuss that a little later, right? But ideally, you should see your distribution very well ideally distributed across all the partition key ranges, because your throughput is distributed across all partition key ranges. Your query workload or your write workload, your update workload is also well distributed, right? If there is a problem, then you can find out if there are certain partition keys which are dominating that particular partition key range, and you can find out more details about them by clicking it up, right? So that's the key concept of monitoring the partition key throughput. Okay, so that's the first part. So let's see. I will just stop here for a minute and then switch back to the presentation. There is one more thing that you can do, which is I'll switch back a little later, is the alerts and the monitors. Let me come back to it in a bit by just coming to the second part. So what happens when you get throttled, right? So what happens is, by default, all the SDKs will retry if you don't override the behavior. How can you override the behavior? There is, on .NET side, there is connection policy, which has an option called as retry options, and you can say how many times you want to retry and how much time do you want to wait. So what really happens when we throttle you? Why we throttle you? Because let us say you provision 10,000 RUs, and for that partition key range, you exceeded the 1,000 RU, or whatever the whatever the RU which was available for that partition key range at that particular second. We will come back and say, please retry after X amount of milliseconds, and you as a SDK user, you can go ahead and retry. By default, SDK does this all automatically for you, unless you want to override this behavior, right? There is a small side impact of the automatic retry, which some customers do not like. Because you retry, the same operation can seem to take more time, right? So what you should do, honestly, is if you want to override that behavior, you override this particular set of options. Okay, so that's the one part. Okay, so let's switch back to what about the query metrics themselves, right? Well, let us say you execute a query, you want to find out how the query is working. So we provide a way to provide you query execution metrics. Once the query is executed, by default for every query, we generate that. You don't have to switch it on. Only thing is, on the client side, you need to tell us, should we return that to you anytime. So the way to do that is here, and I will show you a little later too. And then the third part is the metadata request. So what is this metadata request? This is recently added, as we found out a lot of customers were doing this, facing this issue. So when you query for your collection or your database, use a canonicalized way to access those resources rather than doing any query. If you do any queries, you will basically start hitting the metadata, and that can get throttled sometime. So now let's switch back for a minute and cover pretty much everything, right? So apart from matrix, what do we have? One is the alerts. So you can create alerts, right? There are alerts for pretty much everything that can that you are interested in. You can basically choose the storage is going down or the average requests are going up. Why would you want to monitor this? Because you want to make sure that if the average request is 100 and it has suddenly go to 10,000, I definitely need to do something, right? Or if you see internal server error or so on and so forth. Or other way is number of throttle requests, right? So you can create these alerts. You can create a response mechanism, which is a combination of alerts to you on your email or some other mechanism, but more importantly to automatic to, let us say, Azure function or something like that, which is basically going and either scaling up or scaling down based on your rules. So that's the key part, right? This is one of the alerts mechanisms that we provide. Then we also provide something else, which is pretty, I'll get into that in a bit, is we provide Azure monitors. And this is the place where you will start seeing a lot of our alerts getting pushed. So if you go to Matrix Preview, you will start seeing a whole bunch of things from us, right? So here you can add a resource, which would be, in my case, the account, GSK demo. Okay, and then you will select, let's say, a request, and then you can choose the aggregation that you need, and you can filter it by the collection and so on and so forth. And the good part of that is you might have seen that in the beginning, you're seeing these, right? You can create alerts on these. You can actually programmatically access these things and do something more than what we provide out of the box, right? So this is another way. Now, what about those the other thing that I was talking about with request to the query matrix and the metadata. So let me cover the one small piece, and then I will just show you the query matrix just out of the box. So if you go to the whole monitoring piece, you will see system on one side. So here, whenever you are trying to utilize the access to the databases or collections in a wrong way, sometimes you will see that all these queries are basically logged here, right? You don't want to see many of them here. Occasional one or two is completely okay, but you don't want to see hundreds of them or thousands of them here, because if you access them too much, we will definitely send a throttle to you, okay? What about these other guys, right? These other guys, consistency, if you distribute your data, definitely then we provide you ability to monitor whether we are meeting the consistency requirement or not, right? Availability, as you would see that we of course provide availability, we'll cover that earlier, right? So this is just about done, but what I need to show you is there is a way where we basically tell you how to, so let's do this, Cosmos DB query execution matrix. And so this is the key part. What you do is there is no impact on this on the server side for enabling this. This is always done. Only thing is you can switch it on for your queries and store this information on your side to find out what is really happening. How to do that? You just you just provide a new feed option called as populate query matrix, and you pick up this query matrix. How does it look like? So the latest one has a little bit more information. We give you partition-wise information. Where do you want to focus on? You want to focus on few things, right? One is whether index was utilized. Second is where did we spend time on. Third is how much are used. And sometimes what will happen is number of documents that you looked up or number of entities that you looked up versus number of entities that you returned, right? If you looked up more than what you basically ended up sending, then definitely there is an issue. If index utilization is not good, then definitely there is an issue, right? And then we give you per partition information, how we have done it and how many times we have to retry, because not every time we will, in the first shot, we will not go ahead and get all the data, right? And we can get into these details in another of the sessions just for this, but I just wanted to make sure this is all there, and you should always store this for every query that you execute so that you can find any deviations from what is happening, okay? Okay, so that was that. Let us switch back to the presentation and just speed it up a little bit. Oh, looks like they did not see the demo. Was that was it? I think so. I think that's what it is. Okay, so let's go to the next one, right? So how do you switch on the client-side log? So why would you switch on the client-side log? You would switch on the client-side log to track down the number of retries which have happened, but don't switch it on, keep it on all the time. Why would you? There is another reason to switch it on, to find out whether you are facing any issues on the client side. The majority of the issues that we have seen are basically related to CPU being high on the client side. So, and that in those cases, you will see some issues on your side for the latency purposes. Okay, so that's one part. What about other attributes which can add up to the whole client-side latency? One is the retry, one is the operation. The other pieces are the max degree of parallelism, max buffered item count, and max item count. What are these? As you can imagine, if you do a query which goes across various partitions, you want us to decide how good that parallelism is, and you can set a default which is -1, and we will go ahead and do that. If you don't do that, the execution will be serial. Same thing with buffered item count. The idea here is that we use some memory on the client side to pull data eagerly so that you can get that data. What about the max item count? You don't want to set it very low, otherwise there will be a lot of trips back and forth between server and the client side, and you will see a latency because of that, right? So that's one set of things. What about the index, right? Index, by default, we index everything. You should not touch it. You should use range index, and if you use spatial, please add the spatial point, spatial index piece, but otherwise don't touch it, right? There is no need for you to touch any of the index at any point of time. There is a concept called as lazy indexing. Please don't use it. Normally we have found out people switch it on and then they start doing the queries and they start facing issues because lazy indexing takes time to be consistent. So do not use lazy indexes in 99%, or basically I would say pretty much nobody needs to use the lazy indexes. We provide you consistent index with performance. You don't have to take that particular bit at all, right? There's one small issue that we have seen from time to time. This will be fixed in the coming time. But let us say you do a query on the ID of a document. We don't index it by default. So if you want to do a query, make sure that you create another attribute with the same ID and index it. Or basically just make it part of the document and we'll automatically index it, right? So that's the key part. There is another part that you need to remember is that you can definitely, we automatically enable all the indexing, but you don't have to do that. You can treat Cosmos DB SQL API as a KV store by switching off all the index and making sure that ID of the document is the partition key. In that case, you can have trillions and trillions of keys, and we will just happily support that, right? And you can do that very easily through the portal or through the code. Generally, I would request do it through the code so that you know what you're doing, right? And you would do this. You would not change your index every day. Since we are schemaless, you can push in any kind of schema, right? So you don't want to change index for very large systems. We can definitely support it, but it takes time to do percolate those changes, right? Other thing that you want to do is, let us say your writes are taking more RUs. So you can switch off certain parts within the index. So why would you do that? Let us say while you're reading, you do not provide those predicates in the where clauses, those attributes. You can say, okay, looks like I have about almost 2 megabytes of data, and I only query on 4 attributes. The rest of the attributes, you can just say, hey, just exclude all of them, right? And that you can do pretty easily with Cosmos DB. And you should do that in the beginning itself or as you go along. You will save a lot on the write RU cost. Read will still cost you because the document or the entity has to be pulled up, but write definitely will save a lot of RUs. Okay. Now, there is another thing. Let us say you found an issue that Normally, that there is an operation, whether it was write, then write, you know that you can get the request charge easily. Every operation in Cosmos DB returns the request charge. We have a sample of that everywhere. You can pick up that out. But what about the query? What do you do? So what you can do is there is another mechanism that we provide out of the box. Let me just share that. Let me assume that you are able to see the screen at this point of time because I have not stopped sharing it. So there's something called as log analytics. How do you enable this? Log analytics is if you go to diagnostics of your Cosmos DB, you basically turn on diagnostics log, right? And you will basically log everything which are coming, data plane requests and requests, right? And what we do here is whatever activities you do on control plane, changing the key, creating a new collection, creating a new account versus executing read, write, query, all those operations we log here. Right? You can push that to other locations too, but log analytics is what we're going to discuss, so I will just come to that. There would be a time lag between the time that the operation happens and a time it lands in the log analytics. We are trying to improve it. It can vary from 15 minutes to 2 hours and more. But this is very important for you to basically take advantage of. What it will tell you is, it will tell you something interesting. Which are the operations which are taking, let us say, more than 3 milliseconds, right? Or which are the operations which are taking more RU, right? And which are those IP addresses. Note that we do not push all the complete IP address. We mask out the last bit. For the PII, we do not log the exact query today. But what you can do is, why this is important, because then you can focus on, hey, it looks like my create is taking more RU, right? What is the RU which it is taking? Oh, looks like pretty heavy RU that it is taking at any given point of time, right? You can say request charge, and right, and then right? So it looks like 6 RUs, right? So you can do all these kind of queries here. Why would you do that? Because then your key part of the Cosmos DB is to provision a platform which can take care of number of operations. What are those operations? These are the operations. Create the CRUD operations, right? So you want to know, is there some particular operation which is dominating your workload, or it is going against a particular partition key, and so all those kind of things, all those goodness is basically present there. Okay, so let me switch back to the presentation. I hope you folks are still there. There is a lot of stuff that I can cover, but very simply, this is the summary, right? And trust me, I'm pretty much done with most of the demos or most of the switching between the screens, so you folks don't have to get troubled by that. But ideally, you want to do get, then you want to do single partition query, then you want to proceed with cross partition query, and then finally is the read feed itself, right? Bulk insert with a stored procedure is the best. Because it will push a lot of data together and it will be in ACID format if you want to push a lot of data, than a single put, because then you can save a lot of RUs in that way. You will find that it is far more faster because you don't have to do client and server trips, right? TTL delete is always better because there is a hidden advantage that you don't pay for the RUs utilized for the TTL, and it is instantaneous unlike some other platforms, right? And you should use change feed very often for doing a lot of interesting things that you can do. When things happen in Cosmos DB, what you want to do should be always take advantage of change feed, which is basically Azure function trigger, right? That's what you should use, unless you want to host the change feed processor by yourself. What about the storage? This is key part, right? And this will take very short amount of time. As you realized, you do not have to do storage management. What you need to do is choose the right partition key. As long as you choose the right partition key, your data can grow infinitely, right? You can expire the data as and when you need it using TTL, and you can move the data using Azure function and a change feed, right? Or a change feed processor. Now, sometimes some customers do come to us saying that we want, looks like the data is accessible fast with a particular partition key combination. What if you, for the same data, you need a different partition key? What you can do, you can use change feed, use Azure, use change feed to suck out all the data, put into another collection with a different partition key, right? And then you can do more interesting queries there. This is another way of creating another index, global index altogether, right? Then what about, there are some patterns, and I'll rush through these. What if you have very large documents? As you know, in Cosmos DB, we have entity size limit of 2 megabytes. So what if you have something more, what should you do? What you should do is you should basically either store it, break it down, store extra data within blob or something, or stitch it together, or do not, most importantly, do not index attributes that you don't want to, you're not planning to query. Okay, that's the key part of the large documents. What about partition keys which are greater than 10 GB? As we discussed, that you can have partition keys at 10 GB, and you can have infinite number of these partition keys. But let us say there is a system where particular tenants, let us say you are an IoT system, and you have signed up with someone, and you want to do you want to store all the information related to that particular tenant. So what do? We have a pattern here. You can add a known suffix to the partition key, and when you query, you basically pick up that information. Where is this information? Where is this sample here? We also have a sample in case you really are interested. I'll just switch over. You can go to Azure Document DB, and let me just go and first switch to share the screen so you can see the screen. This will be pretty much because I need to wait till it shares, and then come to this side of the world, and I'm assuming that you will be able to see this. We have something called as patterns, right? And one of the person who has been with this team, Arvind, he has written down all these patterns. So one is basically the large partition keys, and we have a sample here for you to look at, and it's very straightforward. It's basically adding a known entity at the end, right? It could be 2 bytes, it could be 4 bytes, depending on how much data you want to store. If it is 2 bytes, you can clearly see that you can store about 99, which is about 1 terabyte. If you want 4, then you would basically go ahead and store almost a terabyte of data for that particular tenant. So you can store more than 10 GB of data for a tenant by using this technique, right? So this is one part. Let me switch back and come to the last important thing which we have seen with some customers. And is sometimes we see that some customers, actually there's a customer I just talked to yesterday, they design very well. They have chosen a partition key which can distribute very well. Their storage looks pretty fine. But only certain partition keys become very hot in the queries. Then what do you do, right? So there are ways to handle this too. One is you can basically go move your reads across the various read regions rather than going only into a particular region. You can go in and do the read into the write region also. Second part is cache this collection into, identify these very, very hot keys and push them into a different collection altogether. And we have a sample for that also in that pattern, right? The key part here is that you can definitely handle it if there are certain keys which are very hot, and you can basically take control of that, right? You want to pre-aggregate as much information. Don't want to do counts and min-max at the runtime, just like any other good database practice. Either pre-aggregate it or after the fact using Spark streaming, right? Then with regards to availability, what do? You should always add another region. Don't run within single region. Yes, we provide 4 nines within a single region, but you don't want to take a basically dependency on just that, right? The only impact of the second region is, do you have to change anything? No. What you need to tell your client is basically which are the regions that it can go to, and client will automatically find out if a particular region goes down, and it will start redirecting the traffic. You don't have to do anything. Okay, that's the key part. You can also change the write region as you move along. maybe to check the DR of your application, or to follow the sun mechanism, right? There is one thing with availability that with the whole consistency model that you can do when you start distributing your data. If you change your consistency model to eventual, you can, for a given throughput, you'll see that you can push almost double amount of data because it is eventual compared to the strong, right? But generally, it is an application decision, so you want to take that in a very controlled fashion, right? What about the error codes? We document pretty much all the error codes. 200 is good. 400s will be retried. 500 is the only one. There's 500 where you should file support, because that means that we are unavailable at some point of time. We strive to provide you SLA-backed guarantee for not hitting this, but pretty much everything can be retried, and 429s are automatically retried. You don't need to know all these things unless you really are interested. We have documented pretty much all of them, right? What about other things? There is few other things that you will get from time to time. What about bulk load, right? The bulk load, the key part here is, remember, you do not want to sort the data and push that. You do not want to push the sorted data because it will overwhelm a particular partition key. So key concept in bulk loading is that you want to shuffle the data, increase the RU while you are pushing the data. We are planning to release hopefully a service, but you can always reach out to us if you want to do a lot of bulk data migration today. We can provide you offline tools for you to upload the data, right? ODBC as a way of connecting to Cosmos DB is not so great today, because ODBC does not understand all the partitioning and all the distributed nature of the Cosmos DB, right? It will not be good for pretty much any distributed database, right? So that's one part that you need to remember. Backup, you do not have to worry today. Today we provide a backup every 4 hours, and we retain last two backups. And you can restore these backups only when you have either accidentally deleted the collection, or accidentally your application deleted or updated some data, or there was some fat finger issue, right? And you call us today, you basically raise a support case, and we will restore this. Eventually, we are basically trying to provide this completely in a UX fashion where you do not have to approach us. So look forward to a lot more announcements on this particular front. A lot of times we also get customers who want to create a copy of database or a copy of a collection. Use change feed and Azure function and just suck out the data. That's the fastest way. What about paging? This is another thing that you will see. In Cosmos DB, there is a concept called continuation token, and depending on the max items and everything, you can basically get certain set of items, and you can store those continuation tokens because they don't expire, right? Of course, somebody will step in and say, what about the data if changes? Yes, then they are not valid, but continuation tokens by themselves don't expire. So you can always store them and do quick skips, right? We will be providing skip and other support as we go along in the near future. So look forward to that. With that, I will take a break and switch over to questions as I go along, right? So this is what I had to say. Basically, there are very few things that you need to do. Get the throughput right, get the partitioning right. The partitioning, if you get right, and the throughput right, then only thing you need to monitor is whether you're getting throttled. Is it throttled very bad? Is it occasional? The occasional throttle is completely okay, right? If it is very bad, then you need to increase the throughput or decrease the throughput. And you can take advantage of the APIs to do that. You don't have to sit around and babysit the system, right? Same thing with the storage. You do not have to do any storage management. Just choose the right partitioning scheme. We will do everything for you. Availability management, again, you do not need to do anything as long as you add another region. Please always add another region for the Cosmos DB. We make it very easy today to provide that. Okay. With that, I will take a break and I will switch over to the questions. Our next session is on serverless. How to develop serverless application using Cosmos DB, which will focus on Azure function and change feed. Please make sure that you attend it. It will be very exciting. Okay. So let me switch over to the questions and see if I can answer some of them. Okay. And please remember, you can always reach out to govindk@microsoft.com or ask Cosmos DB. So there are a bunch of questions. So let me see which one I can answer and go ahead. So let's. So there is a question, is there any use for lazy indexing? To be honest, there is literally, you don't want to use lazy indexing. We do not plan to take it out, but please do not use today, because what we have found out is many times people end up using it and they face issues when people start querying and they see data is not there, right? Or the queries don't return the expected data. So don't use it. So it is something that I keep on telling customers from time to time, right? On the monitoring feature, is it possible to see the actual queries? So Almar, Matthias, that is definitely a great question. We are working on providing the templated query text, because if you provide actual query, that will not be great, because then the parameters and everything will be there. We will violate a whole set of issues. So we are working towards providing templated query text. So reach out to us if you are interested in looking at that early. I think within this semester, which a semester is basically, we work in every 6 months, so this is our 6-monthly semester. We will be definitely working towards exposing that. Related with my last question, one question is scale up. It will be, I think, I do not, so Carlos, can you reach out to us on Ask Cosmos DB or to Govind K, and I'll try to answer that question. Okay, there is a question from Akila, which is, does requesting the query matrix increase? No, you do not. The query matrix is always produced whether you want it or not. The only thing is when you request to push that data down to the client, right? That is the serialization cost, right? That's the only thing. But we always produce it because we need that information for monitoring everything, right? The only thing that you need to be wary of is the client-side log. So I did mention there is a client-side log also, just like in Java or .NET, there is a way to enable it. That is the one you want to enable only when required, because that file can become bigger, because then you will start logging pretty much everything, right? That is the only thing. But query-side execution matrix, there is no cost. To confirm total RU is distributed across, so this is a question again from Matthias. Yes. Matthias, the way to understand is the throughput is distributed across all partition key ranges equally. Your partition keys are residing on the partition key ranges. So your question about saying, let us say you allocate 10,000 and you have 10 partition key ranges. So each one of them will get 1,000 RUs. So completely right? Okay, can I auto throttle? I think there is a question from Tony. Can I auto throttle Cosmos DB using tools like Puppet and Splunk? No, you don't have to do that. As you saw that you can definitely write a piece of code to reach out to this side. There are customers who try to take out data from the Azure monitor, which I was showing earlier, into Splunk or other places, and then write code to do that. The code to auto scale is very straightforward. As I showed you earlier, there is a concept called as offer. You change the offer, and it is instantaneous. Okay. Then there is a question from KV. Can you monitor an Azure function to monitor for? Yes, you can definitely do that. Yes, you can do that. But remember that we charge you whatever is the maximum in a given hour. So there is no point in changing every minute, right? So you want to be cautious about that part. Okay, and your goal is not to have zero throttles, right? Your goal is like few occasional throttles are completely okay, because system is going to retry it. Your goal is not to have continuous throttling, right? That's the thing that you need to be wary of, right? Partition key question. But I have several telematics customer. So I think, Michael, can you reach out to Govind K? I can definitely help you with this. We have various customers who do this scenario today, and this is very easily available. Just to give you a perspective, we are going to come out with one of the many case studies, but one of the case studies is Azure AD. 10 million plus clients of Azure AD store data in Cosmos DB. So that means anytime somebody logs in Azure AD, anytime mutates their profile, all of that information is stored in Cosmos DB. So you can imagine some tenants are going to be bigger than what is present, right? Okay, there is a question which Anita has answered. So Alex, hi Alex, nice to meet you. This is a very straightforward question. On our pricing, we explain that the RU, the charge that you get for the RU is based on whatever is the maximum RU in a given hour. It's the clock hour, right? The UTC hour. So that's what it is. Ruxar, yes, autoscale is possible using the API that we provide, and eventually we will provide autoscale, but you can implement it. Majority of our customers have done it themselves. as much as I think. Okay, I will, is it okay, right? Okay, I hope folks are still there. Some folks are still there. Okay, I'll answer the other question. Multiple collections in same DB, right? The only reason that you want to create multiple collections or multiple DBs, remember, collection or a container is a unit of throughput, right? So you want to ensure that the minute you need the control on the throughput, let us say there is a hot set of keys, right? And you want to keep them separate, or a hot tenant, you want to keep it separate. That is the only time that you want to keep it separate. Or there is a government requirement that you want to keep that data separate, then you should do that. But otherwise, you don't want to do anything. Or let us say there is different kind of consistency requirement, then you should create separate accounts altogether, because every collection or a container inherits the property. There is a question from Greg Moyer, which says you should mention that the throughput you pick is, yes, you are completely right. When you choose the throughput, we basically create the number of partition key ranges, but that's not constant. Remember, as you push in the data, you can change it. We change it underneath you, right? And you can bring an up, you can move that throughput up and down within that range any point of time. Okay. Okay, there is a question from Andreas. I think, Andreas, we have talked earlier, or I think we're planning to talk. So there is a guarantee on the latency of 1 KB, and there is, you can see that pretty much you can try this out for larger documents too. As long as you're doing point reads and write, you will see same latency, right? So you should, whatever the latency that you see for larger documents, you will see it if you do point read and write. It will not be within 10 milliseconds you will get the 1 KB of document, definitely not possible. But whatever you see, you should be able to get that, okay? There is a question from Greg Moyer again. I noticed when we migrate data into Cosmos DB, it gives us, okay, Greg, we can help you there, depending on what you're trying to do. So please do reach out to us at Ask Cosmos DB or Govind K, and then we will help you out on that. I think with that, there is a good question there by Ruxar, which says, is there a tool to update documents in bulk? You should go to our GitHub. We have a sample of doing update in bulk. We also have updated sample, which can do a lot more sophisticated merges and other set of things. So reach out to us. We should be updating that very soon. But that's one question. When will you support search, Jeremy? That's a great question, Jeremy. I can say what I can tell you is that patience has sweet rewards. So look out for that very soon, very soon. Jorge has information about telemetry data sooner. So Jorge, today the fastest way to see that data is the Azure Monitor. You saw that I was pushing out some data there. That will be a little faster, and you can pick up data from there. But the full data, we are definitely trying to push, and please extend your patience as we work with the log analytics team to make it better. Okay. Sergey, I think you have a question, what is the billing period of Cosmos DB? As we said, it is per hour. How fine-grained auto-scaling could be, as we remember, that is depending on what you want to do. It is the throughput that you set, right? And it can be at the minimum in 100 RUs increment, right? Lucas, you have a question around what is the best practice to run SP on each partition key? This is a great question, Lucas. We have some exciting news for you. You can reach out to us. We are planning to do something similar. Reach out to us. We will provide an update for you for this one. Alex asking about how do I get access to the bulk load. There is one bulk load which is already present on our GitHub, which is the stored procedure. But if you are using Java and let us say you want to pick up data from a blob, you don't want to use ADF or something like that, then we do have other approaches. Or if you're using .NET, then we have some approaches. Please reach out to us on Govind K or Ask Cosmos DB alias. Alex, again, this is a very, I think it's a good, think of distribution of data as partition key problem is basically make sure that particular partition key does not exceed 10 GB. If it exceeds 10 GB, add a suffix to it so that you can have more data accommodated. But that's the key part of it. You can have as many keys as you want, and you can store 10 GB data within that partition key, right? So that's pretty straightforward. David, thank you very much. Is attachment? Yes, attachment is still supported, but I would say that please use Azure Blob directly. That will be the best way to store a lot more data and leverage the Azure Blob CDN and other things for doing a lot more interesting things. Alex has a question. I will cover these questions because I think otherwise it's okay, right? Yeah. Okay. So Alex has a question: when enabling multi-region, does each region duplicate the cost? Yes. So Alex, it's very straightforward because we provide a throughput, exact same throughput across all the regions. So it's the same. It is basically every region that you add basically doubles up the RU that you provision as you go along, right? Because we need to provide the throughput guarantee, we have to reserve the same amount of resources at the back end. Okay. Okay, Jeremy, I think, has a question about roadmap. That's a great question. I think, Jeremy, thank you very much for that feedback. We do look at our feedback, which is Azure. If you go to, there is a feedback system, and we take that as our roadmap to be very transparent, but we will definitely look into this. Bob has a great question about how to facilitate point-in-time restore of data. Bob, I can discuss it offline, but today, yes, you will need to do a little bit of work on your side, actually a lot of work on your side to store data yourself in a blob and then go back in time. But rest assured, something very exciting is coming on this front within the next semester. Not this semester, but the next semester. So we are definitely working on that. Okay. Yes. Ricky has a question about 429s. There is, so it depends on your application, right? 5 to 10 429s or hundreds of 429s. If there are millions and billions of requests or thousands of 429s is completely okay, right? That depends on your application. You decide that what is good enough. Sometimes 429s are not okay. Let us say it's a streaming function, right? The streaming functionality will not have buffering capability. So you do not want to wait for infinitely retry, right? So you do not want to have anything like that there. So the last, Pramod has a question about backup copies. Today we provide 2 free backups, but if you're interested in more, please reach out to us. I cannot definitely say whether the pricing will change, but we can definitely help you to increase the number of backup copies. Yes, you can download the slides. All slides are completely public. Then there is a question about Greg. I think it should be the last question, which is stored procedures. Yes, stored procedures are great for writing. Stored procedures are not great for reading, right? If you read something, you want to write that guy. That's the only thing the stored procedures are good for. Do not think of stored procedures in normal SQL world or for reading everything. You will get far more better reads because remember, we are highly distributed. Every replica, we have 4 replicas, so we can go out and read from any replica and provide you the throughput that you need. So reading from a stored procedure is not a great idea today. It's only great for writing. So with that, I will just take a break here and let you folks remember there are 2 things. Ask Cosmos DB is our email alias, and Azure Cosmos DB is our Twitter alias, and you can always ask questions on all of these. So thank you very much for your patience. I apologize for any screen mix-ups. I'm still getting used to that. But anything else, anytime you need, please reach out to govindk@microsoft.com. So with that, I'll stop here. Thank you very much.
All right. Thank you so much, Govind, for that great presentation. So as I mentioned at the beginning of this presentation, you will be getting a recording as an MP4 at the email address you registered with. We'd also like to ask that you take a moment to fill out the survey on the bottom right-hand side of your screen. This just lets us know how we did today and lets us learn a little bit more about who you are. So with that, thank you so much, everyone, for joining us today, and have a great day.